Hi folks, and welcome back to Physics with Captain Rod. I'm making this video here to help you out with numbers 11, 12, and 13 in your Unit 1 homework about the electric field. So let's get rolling. Let's see, consider the 2-point charges shown. Assume the charges have the same magnitude Q. Draw electric field vectors halfway between them. Find an expression for the net electric field. So pictures may be a little hard to read, but this is, a positively charged particle. Oh, I don't like that green on orange. This is a there we go. A positively charged particle and negatively charged particle both have a magnitude of Q, value not important. Let's talk about halfway between them. So it's like roughly, oops, maybe a little more to the right there. Roughly about here. So ask yourself, what is the electric field direction at that point due to this charge? Right? And the way you determine that, you say to yourself, if I put a positive charge right there, what will the force direction on it be? And that should allow you to draw an electric field. Draw it. Then we're going to write something down for the magnitude. Now remember, the magnitude for an electric field is KQ over R squared. So that's the charge creating it. The R is distance from the charge to the point. That would be this distance. So think about what to write there, considering that's a D, listed as D. Next, we're going to deal with this one. So now you ask yourself, if I put a proton here, what is the force direction due to that charge? That allows you to draw another electric field vector, and then again write out something for its magnitude. Let's see, part B, a distance d over 2 to the right of the negative charge. So that's talking about maybe about here. So you're going to repeat the process. Ask yourself, take this one right here. What is the force direction here on a positive charge due to that charge? That should draw you an electric field vector. And then write out something for its magnitude using this as the distance. Then ask yourself, what is the field direction here due to this charge? Draw a vector, and don't forget, look how much further away it is, and the charges are the same. So you want to try to pay attention to relative magnitudes. And then put in something for, the KQ over R squared, and you're going to use this distance here. So think about what to put there, and then just add them vectorially. Assume the system of charges are all the same. I don't mean to imply they always are, by the way. It's just an easy way to write problems. And it allows me to write questions which allow you to think about relative magnitudes. Find an expression for the net electric field at the lower right corner. So that's talking about this spot right here. I'll just call it P. Now, an important thing to realize, there's nothing there. The vectors we're drawing are not force vectors, they're electric field vectors. It doesn't make sense to put a force vector there because there's nothing there. It's force on what? The answer is there's nothing to put a force on. But you can draw electric field vectors. So at this point right here, you go through each one of these and you ask yourself, if I put a positive charge right there, what will the force direction on it be due to each one of these individually? And that will allow you to draw electric field vectors in their directions. Then write something down for the magnitude of each one of these using our electric field is equal to KQ over R squared. So here's one of the R's from here to here, labeled. Here's one of the R's, and here's a third one right there. Those are the three distances you're going to need. And if you look at that picture, there's kind of a shortest distance, a middle one, mid-ish one, and then a longest distance. That should allow you to actually scale those electric field vectors. Now, once you draw those, the next thing you're going to have to do is add them vectorially. And if I extend this line like this, here is an angle that's going to show up, and it's the same as this angle right there. Anytime you need a sine theta, you can put y over square root x squared plus y squared. I'm getting that from this triangle right there. And anywhere you need a cosine theta, you can put x over square root x squared plus y squared. So that should be enough to get you through number 12. Hopefully, if you're having trouble, get my attention and I'll help you out with it. 13, same type of question. And again, 3 equal charges. This one's actually a lot simpler probably than it looks. So he's talking about this point right here. Go through each one of these, this one, and this one, and draw electric field vectors at that point. And again, the way you do that, you say, if I put a positive charge there, will this thing repel it or attract it? And that will allow you to draw the electric field direction. Same thing for this, same thing for this. Once you do that, you can use a symmetry argument to knock over, I'll just say, one of the electric field directions. And you really only need to worry about, well, you'll end up only worrying about one direction. And I'm trying to decide what to do about the distances because I didn't label any in the picture. But if you look at the picture, I'm pretty sure I interpreted this or meant this to be like D, D, and D. So you should be able to get it down to the electric field equals something. I'll let you decide on a direction, and this should have only K's, Q's, and D's in it. All right, and again, if you need help, ask, and I'll help you out. Sorry about my crummy writing, but hopefully that will get you rolling on that problem. Have a great day.